Hello, everyone, and welcome to the Department of Energy's SBIR STTR FY24 Phase 1 Release 1 Topics webinar. My name is Zina Al-Yusuf. I am with the DOE SBIR Programs Office. I hear some echo in the background. If we can just mute. Thank you. Like I said, my name is Zina Al-Yusuf. I am with the DOE SBIR Programs Office, and I will moderate today's webinar and provide you with some basic topic information as it relates to Release 1. Following this introduction, you will hear from the topic managers that oversee topics 1 through 15 as they clarify their expectation and answer some questions that you may have regarding their respective subtopics. During this webinar, you may submit topics-related questions via the Q&A box located at the bottom of your screen. We will group and present these to the topic managers following each topic presentation. Please include the topic and subtopic number with your question. That will help us keep track of the questions. Also, if you have a funding opportunity announcement or other non-topic related questions, please save these questions for the Phase 1 Release 1 Funding Opportunity Announcement webinar scheduled for Friday, August 11. Finally, a copy of the presentation and the recording of the webinar will be posted on the DOE SBIR STTR website under the Funding Opportunities webpage. The programs participating today are Office of Advanced Scientific Computing Research and Office of Basic Energy Sciences. As you can see, the topics document was issued on July 10, and this week we are hosting the webinars. The funding opportunity is usually released 3 to 4 weeks after the topics are issued. We do this to give you the opportunity to read through the topics document and ask questions so you can make a more informed decision as to whether or not you might have something that is responsive to what we are looking for in this release. The most important date following the opening of the funding opportunity is the letter of intent due date, which is the first step you need to take in order to submit a full application. DOE is the only federal agency that requires a letter of intent. It tells us who you are, what topic, subtopic you are interested in applying for, and a little bit about why you think you are responsive for that subtopic. So basically, if you do not submit that letter of intent, then you cannot submit a full application to the funding opportunity. I hear some echo in the background. If you'd be so kind to mute your mic, that will be great. Thank you. So in addition to the two programs we are covering today, we have Office of Biological and Environmental Research, topics 16 through 20, and Office of Fusion Energy Sciences, topics 21 through 25. This webinar is scheduled for tomorrow, July 19. Feel free to go to our website under the Funding Opportunity webpage and register for the remaining two webinars if you're interested. The registration link is available on the FOA schedule. As we indicated, the funding opportunity is scheduled to be issued on August 7. After that, we will have the funding opportunity webinar on August 11. In this webinar, you will hear from the SBIR STTR Outreach Manager, Dr. Eileen Chand, as she provides an overview of the application process and go over a few changes to the program. So you will want to register for that free webinar. It is also an opportunity for you to ask questions as it relates to the actual application process. However, today we are going to discuss the topics in just a little more insight than what is provided in the topic documents. Please remember to join our mailing list if you haven't done so already, so you can receive notification from us when topics are released, webinar registration, and some good information applicable to each cycle as we move through the phase 1 process. I'd like to bring to your attention that we use GovDelivery, a news application platform to send emails and notifications. Work with your I would like to bring your attention that we use GovDelivery, a news application platform to send emails and notification. Please work with your IT group to allow you to receive these emails from us. DOE Phase 0 Assistant Program is now open to all first-time DOE applicants. So if you have never applied to DOE before and looking for application assistant, I encourage you to go online. You can find the link here or go to our website under applicant resources page and click on that link that will take you to the Phase 0 website, where you can complete a 3-minute application to see whether or not you are qualified for that service. It is a first come, first served service, but it is something that can help you go through the application process. So what's the topic look like? There's an example topic for you. We always have a topic header that is the blue bar you see below the topic title and above the description. And it gives you important information, like if the topic accepts STTR, yes or no, and the maximum award amount for that topic. Not all topics have the same information. They vary by program and by topic as well. So please pay attention to such information. The general topic description explains what the topic is about and maybe some context on where it falls within the mission of the program. Below that, you see the subtopic that describe specific opportunities in which proposals are requested. You will notice that a good number of the topics have other subtopic. Under this subtopic, you can submit proposals that fall within the general topic description, but do not fit with any other subtopics. After each subtopic, there is question dash contact, then the name and email address of the point of contact that you can reach out to with your questions. Please note that every SBIR or STTR application must include the topic and subtopic to what you are applying for. That is just a brief overview. And now we will start with topics for today. We have Oscar, the first topic. Marco. Marco, are you there?
Hello, sorry, I was talking to myself. Good afternoon, everybody, and thank you very much, Zina, for your introduction. My name is Marco Fornari, and I'm a program manager in the Advanced Scientific Computing Research Program, in short, OSCAR, in the Department of Energy. Our portfolio includes applied math, computer science, and computational partnership. In addition, the program manages the leadership computing facilities at Oak Ridge National Lab, Argonne National Lab, and Laurel Livermore National Lab. So Dr. Berumala and I will provide an introduction to the 6 topics that are related to OSCAR work. And the topic manager are online in case you want to ask questions and that are specific to the topic. The first topic, the one that you see on the screen, is accelerating the deployment of advanced software technology. OSCAR has contributed for many years to the development of codes for research purposes across the full DOE portfolio. Research software is usually targeted to specific application and may lack foundation in software engineering, user-friendly documentation, user support infrastructure, and other aspects that facilitates the deployment to a broader community of users. The topic is open to implementation on a diverse set of platforms and is aiming to reach a broader audience for the code that has been developed for IPC supercomputer, but could be portable to smartphone, cloud system, or Internet of Things. This topic focuses on software product that has received OSCAR funding directly or through the SciTAC program. The SciTAC program is Scientific Discovery Through Advanced Computation. A non-exhaustive list of mathematical library, programming models, compiler and runtimes, packages, manager, and software stack is in the description of the topic and in the reference that the program manager has provided. PIs are encouraged to include letters from OSCAR developers in their application to facilitate the connection with specific codes or libraries that are developed within the OSCAR portfolio. Team or small business are allowed under this topic. We have 3 subtopics in this topic: the deployment of OSCAR funded software that is mostly related to application software, and the subtopic related to software library that has been developed under OSCAR sponsorship and are currently portable to a variety of different platforms, and then the other subtopic. The program manager, the topical program manager for this topic are Dr. Al Finkel and Bill Spotts, and Dr. Bill Spotts. So you can address the question to them in the chat or here because they are both present. Any question?
Okay, let me see. If you be so kind for the attendees to put the topic number with your question. I don't see any question for topic 1, Marco.
There was one question, but I think that was taken care by my colleagues.
Thank you. Yeah, I don't see in the chat, in the Q&A box. Oh, there is one. Can you clarify again for topic 1, what letter we need from OSCAR developer?
So this is not needed, but is encouraged, and is a letter of support from people, from the teams that actually develop the software that you want to port for to a broader community. So if you have if you look at the document, with the list of topics, there are examples of software that have been developed under ASCAR sponsorship, for instance, SPAC, and you may decide to bring this software to a broader community. And we encourage to get a letter of support from the people that develop SPAC.
Where can we find the list of ASCAR software?
So there is a list of software in the document that lists all the topics, and under the 01 topic. And this list is not exhaustive because across the year, SIDAC has participated and sponsored a lot of softwares. So you should actually try to find the best overlap by the best information by looking at the software that you want to work on.
Thank you. I don't see any more. Questions here. I guess we can move to the next topic. Topic 2.
Okay. The second topic is about HPC, high performance computing cybersecurity. Of course, there is no doubt that cybersecurity is critical in many areas, but within these topics, we ASCAR try to address the need on massively parallel computing environment with distributed nodes, high-speed interconnected with GPU, CPU, and so on. So we are actually targeting cybersecurity for HPC systems that are more complex by nature than other platforms. It is important to stress that HPC differs from enterprise platform since performances cannot be compromised at all by cybersecurity software. One main goal is to reduce the cyber attack surfaces of HPC system. So the technical manager for this software is Carol Oak, and that is online in case you have questions. It should be specified that the topic applies to cybersecurity solution that reduce risk for HPC system and HPC specific components. The scope includes existing HPC system and HPC specific components, as well as more cybersecure design for future HPC system and cybersecurity tools applicable to future HPC system or future HCP specific component. So there are two subtopics, one that is strengthening isolation between HPC user, that is self-explanatory, and the other topic, subtopic. Any question?
Okay. Let me see. Again, please include the topic number with your question. Again, it says, is there a format for the letter that we can use to reach out ASCAR developer?
Not that I know, no, there is no format.
Okay. I think that's all. I don't see any question for topic 2. So we can.
Excellent. The third topic in ASCAR will be introduced by the topical manager, that is Dr. Perumalla.
Okay, so at this point, we'll move to the next topic. Thank you, Marco.
Thank you, Marco. Thanks, Zina. So this topic is on digital twin capabilities for science network infrastructures. Essentially, high-speed networks are among the key components of the science enterprise. So this topic is concerned with digital twin capabilities for the science network facilities. The digital twins will be virtual companions to the high-performance physical network infrastructures and testbeds that DOE operates. and collaborates with, like ESNet and Fabric. So work under this topic would create network simulation capabilities that will be accurately and reliably duplicated, that will duplicate the operational and performance capabilities of these network test beds for creating their digital twins. So innovation-wise, this is aimed at overcoming the limitations in speed and functionality of existing tools like NS3, Omnet, and so on, in supporting effective digital twins, especially for these large and high-speed networks. So innovations are expected in a combination of parallel execution capabilities, artificial intelligence, AI-based models, and surrogate models, and hybrid models with sufficient functionality in the models to capture the essential characteristics in the networking facilities like ESNet and Fabric. Development of new network simulation tools from scratch is out of scope, as also proposing only partial solutions like tools that don't have a way to incorporate key functionalities like P4 switches. So critical metrics will be, some of them will be that the simulation or emulation that drives the digital twin needs to be at least real time, 1x to even 10x faster than real time for effective exploration and use of the digital twin. Some of the computations underlying these give a requirement of effective event rates of at least 2 billion events or more per real-time second. And in general, the expectation for phase one would be that it would involve the implementation of the digital twin models and software designed for speed, scaling, and functionality. And in phase two, completing that developed in phase one with full meat to serve as a usable digital twin for ESNet and Fabric.
Thanks.
At this point, I can take questions on this
Let
topic.
me see if there are any questions. Yes, will people outside of the core developers of the simulation software be considered for this topic? Have the existing limits been documented?
I'm trying to parse that question. So will people outside of the core developers of this be considered for this topic? I am not 100% sure what the question is there.
If you want, Kalyan, I'll just jump in and say that my interpretation of this question is that since you say you want to build on existing systems, can the people building on those systems be different from the people who developed them originally?
Oh, that's open. Either the original developers or others who can build on existing tools is fine.
Thank you. So this question is answered. Let me see if there are other questions. I don't see other questions for topic 3. Thank you so much. We'll move to topic 4.
Okay, so I'll take topic number 4 from Oscar, and the goal is to facilitate the use of near-term quantum computing hardware. Oscar is substantially involved in the Quantum Information Science Initiative, and this topic focuses on gate-based quantum computer only. Is restricted to near-term, and here I'm stressing the near-term available quantum processors. The aims are software to control calibrate, tune up a quantum processor by controlling, for instance, coherence or perfecting state preparation to mitigate errors, to facilitate the embedding and so on. But also automation of benchmarking and compiling protocols are within scope. No hardware development is going to be considered in scope for these topics. And the PI are strongly encouraged to consider an open source distribution of the software and possibly testing the software on BOE quantum test bed or at least on other existing device.
Hello, Marco?
Hello?
Yes, we lost you for a second.
Okay, so when did you lose me?
Hello?
Hello, I'm here.
Oh, okay, okay.
So I don't know when you lost me. So the subtopics is software calibration, characterization, control of quantum processor, and the technical program manager is Claire Kramer, Dr. Claire Kramer, as the address there.
Yeah, there is a question. Are we developing for a specific quantum system, for example, one manufacturer, or are we building an agnostic software stack?
I believe that both, Claire can comment on this, but I believe that both options are feasible as long as there is an actual device on which the software can be tested and as long as there is no hardware component.
Okay, thank you. Let me see if there are other questions. Oh, in the comment, they lost you at the test bed.
Okay.
Marco?
Oh, okay. I can add. So there are two items that are strongly encouraged. One is to to develop the software under an open software style, and testing is strongly encouraged. It can happen on a DOE quantum test bed that is encouraged, but also on other existing devices.
Thank you. Let me see. Would the testing on research platforms, those in research labs, be on site? It's likely has to be, should we include travel and work on site at the research labs, or should we assume we can connect remotely? Also, is there a link to or information we should rely on regarding existing software and application program interfaces used by existing software?
So this is very specific to the project that you intend to submit. I would say that depends where you want, which kind of architecture you want to use, which kind of device are you working on. And so I think that we should discuss offline how you actually can access the specific hardware that you need.
So you're saying, in another word, also they should send an email with their question?
Possibly to Dr. Kramer.
To Dr. Kramer. For the person who asked the question, please send an email to Dr. Claire Kramer. And please, when you contact the topic managers, put in the title of the email SBIR, STTR, and the topic and subtopic number. put that in the subject line of the email. That way you get the attention. You have a question, you're asking question regarding the topics. Thank you. So
the next topic will be presented by Dr. Parumala.
Dr. Parumala?
Sure, yeah. So this is on artificial intelligence or AI tools for catalyzing interdisciplinary science. So this is focused on new AI tools that will enhance the productivity of the scientists and engineers in their interdisciplinary interactions, like, for example, nuclear physicists and material scientists interacting or collaborating together, or like environmental scientists and computational scientists working together, and so on. So the innovation will be in building on the latest, very recent advances in large language models, also called LLMs, and in interactive AI technologies and generative AI technologies. And in utilizing these LLM-based commercial services that are coming up to enable new interdisciplinary synergy in science, in the scientific endeavor. Outer Scope will be building new LLM models from scratch, or focusing on other aspects like security and hardening of LLMs. Critical metrics will be to include a plan to perform demonstration with scientists and demonstrating the verification and validation of the results, including data validation. That the domains of corpus used, covered by this interdisciplinary tool, should include at least 2 disciplines relevant to the Office of Science. And if you look at the offices, programs under the Office of Science, that will give you an idea of the kind of disciplines covered. One of the questions asked about that, one of our PMs already answered that, I believe. So expectation for phase 1 versus phase 2. Phase 1, a practical initial capability towards that vision that can be reasonably achieved in the frame of really practically 9 months. And phase 2 would be a more comprehensive and effective advancement, building on that, top of that capability developed in phase 1. I'll be happy to answer more questions.
Yes, we have a question. What would be some of the inputs, outputs expected? Would the data, such as publication, be provided or given fields?
The questions, that's part of the research innovation, following the latest trends in interactive use of the back-end AI technologies. So that is part of that demonstration, uncovering the effective ways for that to manifest. The corpus, whatever is accessible to the proposers, and including the open databases, open publication databases, can be used. You can also have the interfaces developed so that the user can link in other corpuses that they may have access to using your API to build on.
Fine-tuning sometimes involves code development and retraining of pre-trained models. The question is if any training at all makes the solution out of scope.
It won't completely. If it's building on the current know-how, we do not want to reinvent and reinvest on something that's already well developed or well established, or already being done by the commercial sector. But anything new that is necessary for this interdisciplinary scientific endeavor is within scope.
Can both fields be subfield of same disciplines? For example, energy?
The word energy is too all-encompassing, so I wouldn't call that a discipline. But if you look at nuclear physics and material science and higher energy physics and so on, these are disciplines. So there is a language in the call that indicates that the Office of Science programs can be looked at each of them as a discipline.
Can you clarify on the list of important disciplines to the scientists?
Sure. Again, the high level is to have interdisciplinary in the sense those that are not necessarily already well conversant with that discipline. As again, going back to this example, an environmental scientist interacting with a computational scientist is an example of the discipline. And if you want a little more specificity, you can safely look at that as each of the programs, 6 or 7 programs under Office of Science as an independent discipline. And I believe Margaret is typing.
Yeah, I also suggested going to the Office of Science website if you want to know more about the areas which the individual offices invest in for basic science R&D research.
Thank you so much for typing an answer and for Dr. Piormala for answering. There's one more question. What specifically are you looking to automate within each discipline using artificial intelligence?
It's not necessarily automation, it's an enabling of the synergy across disciplines. The experts in computational science do not necessarily know much about, let's say, fusion energy, but they know everything about finite element or particle in cell methods and things like that. So they would want to quickly get into that other discipline terminology, the issues of interest, I will throw out some examples I have given here, which is a computational scientist would like to collaborate with a fusion energy expert, then they would need to get an idea of what is the rough size of the problem, what are some of the ranges of the pressures or temperatures that are out there, what are some of the accuracies needed, and so on. These are scientific questions that a technologist can roughly understand, but do not yet know, and they have to uncover those. That the interaction among disciplines would be enabled by such tools.
Thank you so much, Dr. Piormala. No more questions, and we are going to move to the next topic. Topic 6, and also it's you.
Yeah.
Please go ahead.
Sure. So this deals with mixed integer solver technology, especially focused on accelerated computing systems. So what's needed, what's called for in this topic is the computer science needed to address the challenges in scalable, distributed algorithmic techniques. So combinatorial mixed integer programming appears as a key computational tool to solve many problems of interest to DOE and other agencies. So the innovation would lie in novel ways to make effective use of what is called the accelerated computing platforms, which is the current state of the art, which is essentially GPU-based computing right now in most high-performance computing and supercomputing platforms. So there are 2 subtopics. You can propose work spanning either or both. One is on efficient distributed tree management of the branch and cut tree that is often the way to solve these. And second is of efficient linear program relaxation solution. And this can come in the combination of, as a combination of sparse or dense linear solvers underlying both interior or exterior point methods in solving these problems. Note that the items such as cut generation, cut storage, and cut manipulation methods are out of scope, as is out of scope the combinatorial theory development. Column generation methods and aspects like that are also out of scope, and a few more are described in the topics document to make it this topic very focused. Critical metrics will be the efficiency achieved on the GPUs, demonstrating the utilization of the GPUs. And milestones must solve problems in the MIPLib problem set in increasing fractions, again, as specified in the topic description. Expectations for phase 1 and phase 2. GPU, in phase 1, GPU-specific algorithmic design, implementation, and benchmarking, performance benchmarking, should be proposed in a way that is reasonably achievable in, let's say, practically in 9 months. And phase 2 will involve a robust scaling increase of that capability and scaling to GPU-based supercomputers that DOE has.
Thank you. I don't see any question in the Q&A box. So we'll move to the next topic, topic 6. Topic 7. Thank you, Dr. Pramila, for presenting, and Marco as well. Now we're moving to BES topics. Eliane?
Yes, of course. I'm Eliane Lassner, and I'm Program Manager for the Scientific User Facilities Division on the Office of Basic Energy Sciences. I will briefly cover the topics, but I would like to first say a few words about BES. BES supports fundamental research to understand, predict, and ultimately control matter and energy at the electronic, atomic, and molecular levels. We also have premier scientific user facilities, which my topics always address, including X-rays and neutron sources and the nanoscience science research centers, and SRCs. We have 5 X-ray sources, 2 neutron sources, and 5 NSRCs. There's links in the introduction for the topics in the FOA that you can refer with is describing what we do and what our aims are. So for other links in the FOA, we will also give you information about the user facilities. So a little bit about these user facilities. They are undergoing a lot of upgrades that will turn them more efficient, more powerful in producing brighter either X-rays or neutrons, and the topics in general address the needs brought about by these upgrades. So for topic C5707, another thing I would like to say about all the topics, please send me questions with specific references to the topics that you want more technical information about. We'll either, if I have the answer, or if I don't, I reach out to experts. But please make the questions specific. In general, the descriptions and the references are enough, should be enough to give you an idea of what the topics are asking for. But anyway, the first topic is the cost-effective cryogenic, is really asking for cost-effective. That's the emphasis. We have high precision X-ray silicon mirrors, crystals that are undergoing very high power density illumination. And we needed that these mirrors and these cryos be cooled down. Now, there are many available cryosystems that are very specific and they have all the requirements that we are asking for. However, the emphasis here is that we want them to be efficient, but we want them to be cost effective. So we're looking for companies that provide innovative designs that build systems offering similar performance to the ones being offered, but a significantly lower cost. And of course, they offer the same cooling power that existing systems have. The phase one should provide the design concept, expected performances, and estimated costs. And phase two would build and test a prototype that demonstrates the design and the performance of the proposed system. So, it's, as I said, specific questions about the requirements, please send them to me, the technical questions. If there are any non-technical or wide questions about the topic, I probably can answer now.
Okay, thank you, Elian. I don't see any questions for topic 7. Okay, I see questions coming.
I have one comment too, with respect to other. The other topic is subtopic in general is very sensitive. So we will answer questions and we will open proposals to subjects that are within the topic, but not that the link is so small that it doesn't make sense for you to apply. So make sure that within the large topic that you are offering something that has not been explicitly asked on the subtopic, but it does fall very well within it. Okay?
Okay, thank you.
So for the topics, the next topic,
Yeah.
08.
Next topic.
Here we are seeking domestic large-scale fabrication of supermirror reflection surfaces for neutron guides, mirrors, polarizers, and filters. These are high-quality components that help improve signal-to-noise or sample beam flux or even resolution and provide a novel capability that enable neutron techniques. So these are specific for the neutron facilities like the spallation neutron source and the HFIR, which is neutron reactor-based neutron product. For this kind of high-quality components that are essential to prepare the incident neutron beam, we are focusing we are trying to provide the new instrumentations that are going to make this new facility, they will provide the requirements for the new facilities. Specifics are also described in the topics files. And for phase one, we are looking for proposals that will provide the design components, the design concepts and performance expected. And the phase two then should include the building and the testing of prototypical systems and devices that demonstrate the design performances proved in phase one. Again, specific questions, parameters, please send them to me and I'll ask the experts.
Thank you, Elian. There's one question. What is the expected TRL for this topic?
In what sense?
No further. That's all. that the person regarding the proposal. Yeah, that's what the regarding the proposal.
Yeah.
The expected TRL for this topic regarding the
Well, the facilities, some of them are upgraded right now, and some will be upgraded in 5 to 10 years. So they are designed or being designed right now. So you should have a TRL of 5 years or 10 years, right?
Thank you so much. I don't see other questions for topic 8. So we'll move to the next topic.
So the final topic is software tools, data movement systems. And again, because of all the upgrades, all the new instruments, the high repetition rate of the new facilities, data is being produced and will be produced at an extraordinary level. So we are looking for 2 things. Subtopic A, we are seeking machine-guided visualization tools that explore and coalesce multi-channel, multimodal, nanoscale imaging data. And second subtopic is for efficient high-performance data transfer for massive data analytics. So subtopic A is the development of machine-guided visualization tools that explore and coalesce multi-channel, multimodal, nanoscale imaging data. These are very difficult and require substantial effort. We are looking for companies that develop a set of coordinated software tools that can simultaneously visualize multi-channel and multimodal 2D and 3D imaging data sets. Requirements provided in the FOA or the topics and also the references. This SBIR phase 1 that is successful would provide design concepts, expect performances, and of course, phase 2 would develop the code and test the software, demonstrating the design performance, like all the previous ones. And this subtopic B, efficient high-performance data transfer over SNAT, and I will clarify for massive scale data analytics, the need of streaming data at high speeds over the Department of Energy Sciences network, so-called SNAT, for the upgraded X-ray light sources to a DOE supercomputing center and later to the DOE high-performance data facility. This will be critical for real-time processing, for on-the-fly adjustment, for more efficient measurements. So we are looking for the exploration, more than hardware components as used in and already composable infrastructures in combination with original data mover software. And this would meet the 4 goals of simplifying, boosting efficiencies, and minimizing or reducing the energy consumption of data transport systems. But this is specific for the X-ray light sources. Phase 1 projects would provide the design concepts and expect performance. In phase 2 would build the hardware system, code software, and test the entire system. And that's the end of my topics. If there are no questions.
I don't see any questions in the Q&A.
Yes, there is a cantilever mirror mentioned in reference a typical application. Send me the specific question. I'll send it to people that do neutron work.
Okay, thank you so much. So we'll move to the next topic. Topic 10, Claudia.
Is she here?
Claudia, are you online?
If Claudia can't,
I see that Claudia is online. However, we can't hear you, Claudia.
yes, she is.
Let me type a message to Claudia.
Hello?
Hello, Claudia. Yes, go ahead.
Can you hear me now? All right, great. It's like
Thank you. It's all yours.
so many microphones here. It's not clear what's on. Okay, so everybody's good now?
Yes, yes, great.
You still hear me?
Yes, I can hear you.
Okay, I was hearing an echo, so I have to close some things. Okay, so my name is Claudia Cantoni. I am the program manager for Experimental Connects Matter Physics. This program is in the basic energy sciences also. And this program supports R&D aimed at the understanding, the fundamental understanding of quantum physics in advanced materials, which can translate in new functionalities that can be exploited for next generation microelectronics, for example, or for quantum information science hardware. In general, as Eliane said before, BES supports R&D and development of new technologies that can advance the operations and the instrumentation capabilities of the scientific user facilities. In particular, in this case, we are talking about advanced characterization of nanoscale materials and energy relevant materials. So the relevant user facilities in this case are the 5 nanoscale science research centers. What about this particular topic? What is this topic about? This is for the characterization, in fact, of magnetic nanomaterials. So we're looking for the development of a commercially viable electron source that is capable of providing ultra-fast, so time-resolved, and spin-polarized electron beam. Now, because the spin-spin interactions between an electron beam and a sample are larger as the energy of the beam is lower, we are looking at surface-sensitive techniques, or instruments. So we're not looking at transmission electron microscope, but we're looking at scanning electron microscopes or the so-called spin-polarized low-energy electron microscopes. Obviously, this is not available commercially right now. So there is no electron source that is pulsed and ultra-fast and spin-polarized at this time. But this is very appealing because this will enable real space investigation dynamics of magnetic textures, magnetic domains, and this is crucial for the development of new magnetic data storage, sensors, new spintronic devices, and also many other surface-sensitive energy-relevant mechanisms. It is important to say that, so with this, we just have one subtopic for this topic, and these topics seeks basically the development of an electron gun from a gallium arsenide emitter. This is because the gallium arsenide emitters are the most studied so far and the most developed. We have another topic that you can refer to in case you have additional ideas for another emitter, for example. So the electron emission is stimulated by a circularly polarized pulsed femtosecond laser. So the experiment will need to be done, with a pulsed laser. The characteristics specification of the end product at the end of the phase 2, what we would like to see is as a deliverable is a prototype spin polarized pulse electron gun that can be integrated into a commercial low energy SEM or SPLIN. The specifications are pulse width of the order of 100 femtoseconds at around 80 megahertz, emission current in the nanoamp range, spin polarization greater than 10%, energy distribution of the order of 200 millielectron volts, and time resolution less than 1 picosecond. In terms of specification for phase 1, what we expect to achieve at the end of phase 1, we think phase 1 could achieve a proof of principle pulsed emitter to enable measurements that will compare the operation of the pulsed laser to a continuum wave laser. Of course, phase 2 will have to involve more stringent measurements to test basically the time resolution, the energy resolution, and polarization. I don't want to talk too much. I'll just see if there are any questions from the audience.
Thank you, Claudia. There's a question for subtopic B, spin polarized and time resolved electron beam source for electron microscopy or for other. Would time resolved sample preparation topics be accepted?
Time resolved sample preparation. I don't quite understand the sample. If that, so this topic is for the develop like an in situ technique for a transmission for a scanning electron microscope. So it's not to make the actual sample. I don't know if this is related to the emitter or I just need some specification on that.
Okay. Is there a specific quantum efficiency required for GA's photo code?
I don't think there is, honestly. I mean, I think that the specification that we're looking for is basically a polarization that is larger than 10%. Now, I don't think there is, a specific quantum efficiency that you have to, as long as you get that polarization. But if you want to formulate, a better question, and I can ask the experts. I'm not the expert in gallium arsenide quantum emission, honestly.
Okay, thank you. What is the wavelength to be used for pumping? What is the targeted efficiency of beam source?
Yeah, I don't know about, honestly, I don't know about the wavelength that can be used for pumping. I don't think there is, a specific wavelength, as long as the pumping is efficient in producing the desired time resolution. And for about the minimum electron beam current. Oh, the minimum current. What kind of minimum current? If you email me these questions, I can ask the, as I said, the expert and get you an answer on if you're really looking for a minimum current. The topic says that the current needs to be in the order. So the emission current needs to be in the order of the nanoamps. You know, it depends. I guess the minimum current depends on really the material and the experiment you're trying to make, but I can give you some more specification if you send me an email.
Thank you, Claudia. And I typed also to send an email to...
I will assume that the current cannot be like in the range of picoamps, so that would be way too small. So.
Thank you so much. No further questions. We'll move to the next topic. Topic 11, Raul. Let me see if Raul is online. I don't see Dr. Raul Miranda online. Eliane or Cara, can you say something about the topic?
I can read what I have.
Okay, go ahead, please.
Okay. High performance materials for nuclear application? No.
No, it's topic 11, artificial intelligence.
Oh, okay. I have this as BS research. Seeking development of artificial intelligence and machine learning-based signal processing techniques for high-resolution imaging of fracture systems, structures, and dynamics in rocks. This 4D imaging will improve the predictions and understanding of failures in geologic energy waste storage, and energy extraction reservoirs.
Okay. I don't see any questions. Since Dr. Miranda is not available, please feel free to contact the topic manager. And the email is in the topics document as well as in the slide in front of you. Please feel free to reach with your questions. We'll go to topic 12. You have something for topic 12, Eliane?
No, I don't.
Okay.
I don't.
In that case,
what is the topic? Can you tell me?
Rare earth and critical element recovery via selective membranes, AI/ML guided membrane development.
No. Would you know from who is the program manager?
Raul Miranda.
No, I don't have anything.
Okay, please reach out to Dr. Raul Miranda with your questions. We'll move to the next topic. Topic 13. Derek, are you online?
Good afternoon. Yes, I am here.
Good afternoon. Good afternoon. Go ahead.
So my name is Dirk Cairns-Gallimore. I work in the Office of Nuclear Energy. I'm the Advanced Materials and Manufacturing Technologies Program Lead. Myself and my colleague here, James Willett, will kind of go over the two topics, and I'll take on the first one, and I'll hand it over to him here shortly. The Office of Nuclear Energy deals with almost all of our aspects with our current reactor fleet and advanced reactors. That's include materials, components, construction activities, and we have two categories and another category to go over today. The first one is associated with advanced manufacturing capabilities, and those specifically around powder metallurgy, hot isostatic pressing. And some of the development that we've been seeing over the years of both in the 316H, grade 91, and several other materials, we're seeing differences in performance of these materials versus their wrought and forged counterparts. And so this activity is really about how do we both improve and understand materials performance and capabilities as they are manufactured through the PM-HIP activities. And it's a broad category. We're looking at from materials properties, the PM-HIP activities themselves, powder chemistry, cyclic behavior, and so all of those and potential other activities associated with PM-HIP would be of interest to the department in here. With that, I'm going to hand it over to my colleague, James.
James, are you online?
Yes, can you hear me?
Yes. Yeah.
Okay. I had a problem there for a second. This subtopic deals with chlorine.
James, we hear background.
I'm not sure.
You are muted.
Can you hear me now?
Yes.
Okay. All right. This topic deals with the capture and recycle of chlorine gas. There are several pyrochemical recycle recovery processes that might involve the evolution of chlorine gas mixed with an inert gas. So it's not in air, it's an inert gas, typically argon. So there's a need to capture that and then be able to release it back into the process downstream or at some other point. Noted in the description, some of that's motivated by desire to conserve chlorine-37. Several molten salt reactor concepts involve that. So chlorine-37 is now would become a resource to conserve, but in other cases, some molten salt reactors do not involve enriched chlorine. In that case, they're producing chlorine-36, and the desire is then to be able to keep that in the system and not produce more by using fresh chlorine. So the need is for something that would absorb chlorine and then be able to re-release it without any contaminants. There might be
we have echoes back again.
Okay, echoes not me. So the there might be some salt vapor in conjunction with the chlorine and the argon. So some way, if the absorber would have to either be able to tolerate that or have some way to probably trap that before, upstream of the chlorine absorber.
Okay. We have questions submitted. We'll start with the first question. Can you provide further detail on this topic and technologies that are focused on high performance material for export be considered?
Is that for this general topic or?
the person did not include the subtopic, so it's hard for me to tell.
Right. I would think this would be more the subtopic A or other. Dirk, can you speak to that?
So most of the activities here, what we want is not necessarily going to be for the export market. We really do want to focus on capabilities that can be used by U.S. industry and U.S. reactor concepts.
Thank you.
Thank you.
What is
the
effective
thorium
as high with current lab help building for this topic?
So most of these topics, both the topics that we have here, are not actually associated with the fuel itself. And so one of the challenges is that that's not going to be the focus. So it doesn't matter if it's thorium or uranium. That's not the focus of these topics.
Okay. This material for nucleation. Can you provide further topic and technology focused on this material for it's considered not use?
I'm sorry, you broke up. I did not actually hear the question.
Okay. I hear myself. Can you read the question in the Q&A box?
Which one was it?
Topic. E57-13, high performance for nuclear application. Can you provide further detail on this topic? Can technologies that are focused on high performance material for export be considered, not domestic use?
So no, I mean, right now that these topics are associated with for the nuclear industry of the United States. So the primary focus is for the use here in domestic use. You know, export is considered after that. So focusing on capabilities and topics that are exported would not be conducive to the scope that we're asking for.
Thank you. Subtopic C. My understanding of the Melton chloride fast reactor is that CI-37, 24.24% is needed, but CI-35, 74.74% has to be avoided. CI-35 act as poison, parasitic, neutron absorber. One is avoiding a production of CI-36 is a problem in geological disposal, has long time life, and there are no neutral geological barrier. I'm not sure if that's comment.
Yeah. Again, this topic is not chlorine-37 specific. There are multiple applications where it's desirable to capture and reuse chlorine, not just, this is not hinge on cost and conservation of chlorine-37. This is not a chlorine isotope separation. This topic would not be changed or benefit from an improved chlorine-37 isotope separation. As I said in the written response, that because of the scope of the topic, isotope separation proposals under this subtopic would not be considered relevant.
Okay. There's a question for 13A. Are there specific material of interest? Is there a focus on existing steel alloys, or would proposing a new material also fit within this topic?
Yes, we're interested in all alloys that would be of interest to the nuclear community. So, you know, as I mentioned earlier, the two that we've had the most that we've worked on internally are 316H and grade 91, but 709, 617, ODS alloys, high performance nickel alloys, all those different categories would be of interest to us.
Okay.
Okay.
Can you clarify the material you're interested in? Next, super alloy, tungsten.
So like I was kind of indicating, we're broadly interested in any potential high performance material that can be used for structural materials in a reactor. And so we're not limiting the scope to any specific materials.
Okay. There's no, what material is of interest for powder metallurgy, grade 91? This is for subtopic A.
That's the same answer as the previous one. I mean, we're not limiting to any specific material. There's a lot of different materials that are of interest to the community, so any that can be produced through powder metallurgy HIP would be of interest.
Thank you so much. See any other questions? So we'll move to topic 4. William,
are you?
Yeah, I'm right here. Hopefully you can hear me okay.
Yes, I can hear you. Go ahead.
All right, perfection. Well, yeah, we will get started on this subtopic right here. So it's generally part of the advanced subsurface technologies area. And actually the topic that we've been thinking about lately in geothermal could be surface or subsurface based. What we've been thinking about are the complexities of two-phase flow. And by two-phase flow in a geothermal sense, what we mean is brine and vapor that's being produced from the geothermal reservoir. Becomes very challenging to understand the properties of a two-phase flow system as it enters, well, as it comes from the production wells and enters the power plant. But that's a very critical piece of information for us to understand how to run our power plant to optimize it. So what we're thinking that we would like to do is improve the accuracy and lower the cost of real-time continuous multi-phase flow measurements from individual production wells, such that we can enable improved management of geothermal reservoirs and power plants. One of the, again, yeah, like I was alluding to, some of these critical properties like mass flow and enthalpy in terms of this brine and vapor that's being produced. Currently, these kinds of measurements are typically completed on a bulk level. That is, they would be completed at a point where all of the flow from each of the several production wells has been combined, and this bulk flow is now going into the power plant. So it's good to have that. It's good to have that measurement, and usually the current state of the art is only getting that measurement potentially a few times per year. It's not continuous nor terribly real time. So what we would like to do is have a better measurement that we can have in our system that gives us mass flow and enthalpy, for example, of each of the production wells, so that we have an understanding of what various zones in the reservoir may or may not be doing, and also have that be on more of a continuous and real-time basis. And what that will help us do is really understand our production field, all the way down to individual well bores. So that's kind of what we're going for here. And in terms of, a little further, clarification on what we want. Some of the properties we'd be most interested in, like I've been mentioning, are flow rates, also temperatures, critical item liquid and vapor fractions for these two-phase flow systems, potentially chemical composition. And again, what we're looking for is to understand this at an individual well level, or even sometimes the piping can branch off more than that. So at the most granular level we can understand it, that's where we want to go. Now, even though this is the advanced subsurface technologies topic area in generally, we could see that these technologies could be based in the subsurface or perhaps on the surface, depending on how the measurement is being done. And then, ultimately, the technical goal is just to allow us to understand our flow that's coming from each of the production wells from a thermodynamic standpoint, such that we can better understand individual changes in production wells or various zones of geothermal reservoirs, whereas right now it's a bulk measurement, as I was talking about earlier. So again, what we're looking for is everything that I've mentioned: key items, two-phase flow, individual production wells. We would generally see these as being applicable to electricity generating geothermal power plants. That's where you have high enough temperature to get this two-phase flow. And then what we are not looking for would be measurement of more standard flow data via traditional technologies that doesn't include this two-phase component. We're also not looking for technologies related to ground source heat pumps, as those don't typically achieve two-phase flow. Same with direct use applications, or kind of a catch-all, just gathering of other data that's not of interest under this subtopic. In terms of critical metrics, probably, the thing to remember in geothermal is typically the heat that's under our feet here. So we are, at least from the production well, we're looking at elevated temperatures that are greater than 390 F or approximately 200 degrees C when we're in that electricity production zone. Let's see, as far as references, I included those below the topic area description. They're mostly documents found on the main website for the DOE Geothermal Technologies Office. One other key item that I'll mention, we have a geothermal data repository. The link is included in the topic area description. There might be some useful data sets out there that could be used as part of these projects. So I'll mention that. Oh, and expected partners. I think it's pretty open here. This is a technology that's probably pretty early on in its TRL level, at least as it relates to geothermal technologies. However, I will mention that the oil and gas sector has taken a look at this problem and made some progress on it themselves. So that may be a helpful area to investigate for potential applicants, is to work with some of those oil and gas entities. And the key thing to keep in mind there is that a lot of oil and gas in production is at lower temperatures. So the technical challenge maybe to have, sensors potentially or other technologies that survive at these higher temperatures. And then the last thing I'll mention, on a phase 1 versus phase 2 effort, we're pretty open-minded on this one, because this, I would say this technology is definitely more or less in its infancy for geothermal applications. So phase 1, we would generally expect engineering design, materials development, modeling with potentially some laboratory scale testing. And then in phase 2, we would kind of foresee that moving forward into a model validation, prototype development, or pilot or field scale testing phase. So that's what we would envision. But again, we're pretty open-minded here. So those are suggestions. And I think with that takes care of most of my description. My name is William Vandermeer, and my contact information and email is included at the bottom of the topic area description. So I think that takes care of it for me. I'll see if we have any questions.
Thank you, William. Yes, there is a question. Oh, I too. Does this topic Does this topic solely focus on the development of direct measurement tools? Are data analytics approaches considered for this subtopic as well?
Yeah, for sure. We could see this as being, either focused on development of sensors or tools. Again, they could be surface or subsurface, but also definitely on the model and validation side as well. Or it could be a combination of both of those. So that would definitely be inbounds for this topic area.
Thank you. Would you be open to a direct application to phase 2 if we already meet the phase 1 deliverables?
Let's see. I guess what I would say, from a technology standpoint, we would be open to that. And I guess what I'm going to do is try to answer that in the sense of a phase 1 SBIR call. I guess I'm not totally sure if folks can just skip ahead to a phase 2 under this call, given that it's phase 1. So I guess I'm answering a question with a question.
Yeah, well, to the person who submitted that question, please save that this question for the FOA webinar, as it looks to me it's more related to the application process rather than the technical content of the topic. So please save it and ask the question on August 11 during the FOA webinar. Thank you. At this point, there is no more questions. William, thank you for presenting.
All right. Thank you. Appreciate it. Have a good afternoon.
You do the same. The topic 15 is a technical transfer opportunity or TTO topic. We normally do not cover these topics, but I see the topics managers are available. So if you want to elaborate, Dava and Elian, it's all yours.
Oh, certainly not prepared for this because it was explicitly told that we would not look at the TO, but I can actually read the very high level for advanced X-ray emission spectrometer. We are seeking industrial partnership to rapidly commercialize and deploy advanced emission spectrometer capable of simultaneous measurements of multiple emission lines for various X-ray emission techniques, enabling the interrogation of various mixed elements species to extract electronic and molecular information in materials. Technical questions, please send to me and I'll send it to the specific expert. And the second is the force neutral adjustable phase undulator that I know a little bit more because it's more of my alley. And we are looking for industrial partnership to commercialize and deploy a new generation undulator, which uses a force neutral adjustable phase undulator technology, making high precision, long undulators more compact, cost-effective, straightforward to operator, and thus improving X-ray facilities performance. This is a very, very nice technique that actually allows the superimposition of several undulators on the same space. It's extraordinarily, it's actually is normal conducting, not superconducting. And I am particularly very interested in seeing this going forward. Again, more specific questions, more technical questions about parameters, sending them to me.
Thank you, Elian. We, like I said, we normally do not cover the technical transfer opportunities topic. So for any questions, please contact the topic managers. The email addresses that you see on the screen, and they're also in the topics document. Thank you, Elian. With that, we come to the end of our today's webinar. As we mentioned at the beginning, We will post the slides and the recording of the webinar on our website under Funding Opportunities webpage. Here you have our contact information. Please feel free to reach out directly to Carl Hebron, who is the operation manager in our office. Carl and his team can answer just about any questions you may have about the application process. That will do for today's webinar. And remember, we have 2 more webinars on July 19. That is tomorrow, July 26. If interested, please go ahead to our website and register for these 2 webinars and join us. Thank you for attending today's webinar, and have a good evening.